Alright, Unit 3 is going to be all about polynomials. Today we're going to start off with a review of our exponent rules. But before we do that, we're going to review a little bit of vocabulary. So, the first word we need to talk about is what is a monomial. If we're going to talk about polynomials, we should probably talk first about what a monomial is. So a monomial is one term. It can be a number, a variable, or a product of the two. What it cannot contain are variables in the denominator negative exponents or variables under roots. By the way, product means an answer to a multiplication problem. So we can have a number multiplied by a variable, and it would still be a monomial. Alright, a constant is a specific type of monomial. It's just a number. You know that constant is something that does not change. It is a monomial with no variables. A coefficient is the number in front of a variable. You should already know that term. And then the degree of a term is the sum of the exponents of its variables. This might be something newer for you. It's the sum of the exponents of its variables. Again, keep in mind that that word sum means add them together. If it was a constant, the degree would be 0. A power is just the exponent. We'll do some examples of figuring out degree in just a minute. The last three terms here are all related. A binomial means that we have a polynomial with two unlike terms. Trinomial means we have a polynomial with three unlike terms. And a polynomial can be many terms, or it could be just one term, really. It can be a monomial or a sum of monomials. When we talk about finding the degree of a polynomial as a whole, we want to find the degree of the monomial with the greatest degree. I'll show you an example. If I gave you a problem that started off with x squared y to the fifth plus x to the third minus y to the fourth. we could find the degree of each term and say the degree of the first term, we have to add the exponents together, so 2 plus 5 is 7. The degree of the second term is just 3, and the degree of the third term is 4. But then the degree of the polynomial as a whole is the highest one of those. So the degree of the polynomial would be 7. Alright, let's get into some of our exponent rules. Negative exponents. Hopefully most of this is review. For negative exponents, you want to send negative exponents to the bottom to make them positive. So in this first example, x to the negative third would become 1 over x to the third. And if they're already negative in the denominator, we would send them to the top. When we're multiplying exponents, then you want to add their exponents together. So in this example, x to the third times x to the seventh becomes x to the 10th power, not x to the 21st. When we're dividing with exponents, we want to subtract their exponents. There's a couple ways that you can think about this. You could think of this first one as 5 minus 2 gives you x to the third. But what about when you have x to the third over x to the 8th and you get something that's negative? The way that I prefer to think of dividing is actually from Mr. Kerfus, thinking of it as a battle. So x to the 5th really means we have 5 x's on top, and x squared means that we have 2 x's on the bottom. Think of them as doing a battle. Each guy on the top can kill off one guy on the bottom. So how many guys are left? Whoever has more guys wins the war. So in our case, for this example, we have more x's on top, so the top wins by 3 guys. Then when you're trying to think of the second example, x to the third over x to the 8th, you can just think about the fact that x to the 8th has more guys, so he wins the battle by 5, and the x to the 5th stays on the bottom. If there's nothing left on top, then you write it as 1 over x to the 5th. Alright, we've got just a few more rules to cover. If you have something that's a power to a power, this is when you multiply your exponents. So x to the 4th to the 3rd power becomes x to the 12th power. Remember that when we're multiplying things with the same base, that's when you are adding their exponents. So this is when you actually multiply. The 0 exponent, everyone's favorite. Anything to the 0 power is 1. But you have to be really careful about parentheses with this. This means that, yes, x to the 0 equals 1. It doesn't matter what x is. 500, x to the 30th to the 0 power, is still just 1 because the whole thing is in parentheses being put to the 0 power. But be careful on this third example, the 2 is not being put to the 0 power. Only the y is. So this is really 2 times 1, which equals 2. Alright, the last property to cover are the product and quotient to a power property. What this is saying is that you just need to distribute whatever exponent is outside of your parentheses to the top and bottom of a problem. So for the first example, xy squared becomes x squared y squared, and x divided by y to the third becomes x to the third divided by y to the third. let's try some examples where we put all of this together. Okay, so for this first one, we need to distribute the third power to every single term inside the parentheses, including the -2. Since we're putting, for the other terms, a power to a power, we're going to multiply the exponents. -2 times 3 is -6. 3 times 3 is 9. Then I just simplify. -2 to the third power is -8. b to the -6 I'm actually going to send to the bottom so that it becomes positive, and I'll keep the c to the 9th on the top. So my final answer is -8 c to the 9th b to the 6th. A couple things to keep in mind there. A negative number to an odd power is going to stay negative. Whereas if we were putting a negative number to an even power, it's going to turn to positive. Think about when you square a negative number, you know that it would turn to positive. But if it's an odd power, the negatives don't cancel out. Alright, the next one we need to start by distributing the exponents that are outside of the parentheses. So for the first grouping, I've got m to the 16th, n to the 24th, times, in the second grouping, m to the 18th, p to the 12th, n to the 12th, and p to the 30th. Then I've got to combine my like terms. I'm multiplying here, so m to the 16th times m to the 18th becomes m to the 34th power. N to the 24th times n to the 12th power becomes n to the 36th power, and p stays just to the 30th power. Alright, for number 3, again I want to start by distributing that exponent to everything in the parentheses. So I'm looking at -2 to the 5th, a to the 5th, over b to the 10th. Don't forget to distribute the exponent to the bottom as well. -2 to the 5th is -32. A to the 5th over b to the 10th. Nothing else for me to do with that. Keep in mind that you cannot turn -32 into a positive number. Think about it as -2. If I gave you that, you don't get to send that to the bottom and make it 1/2 and turn to positive. So only exponents can be turned to positive by being sent to the bottom, not numbers. Alright, for number 4, again, I'm going to start by distributing to get rid of my parentheses. So I've got -2 to the 4th power. For x, I've got 3n times 4, which would be to the 12n power, over x to the 2n times 4, which is 8n, and y to the 12th. Now, my x to the 12n and x to the 8n are going to do battle. I know that it seems goofy having an n in there, but 12 n's over 8 n's, the top wins by 4 n's. -2 to the 4th turns to positive 16. So 16 x to the 4n over y to the 12th is my final answer. Alright, the last one, I don't have anything on the outside of my parentheses on the top, so I'm just going to go ahead and multiply. 3 times 5 is 15. X to the -2nd times x to the 1st becomes x to the -1st. Y to the 3rd times y to the -8th is y to the -5th. On the bottom, x to the -3rd to the 4th is -12th, and I have y to the -2nd. Now before I do battle, I'm going to work on making all of those exponents positive. So I'll keep the 15 on top. I'm going to switch my x's, so the x to the 12th goes to the top, x to the 1st goes to the bottom, and now they're positive. And same thing with the y's. Send the y squared to the top and the y to the 5th to the bottom. Now they can do battles. So now I'm going to still have that 15 on top. For the x's, the top wins by 11 guys, and for the y's, the bottom wins by 3. So from all of this, I have a few keys to help you with simplifying. The first thing that I'm doing each time is getting rid of the parentheses. That might mean distributing an exponent, it might mean multiplying, but I want to get rid of those parentheses to make it a little bit easier. Once my parentheses are gone, then I like to make all exponents positive. And then I can do my battles or combine like terms.